All right, well, this is the last section that we're going to talk about in Chapter 9. It does go on a little bit further, but we're going to go ahead and skip the second half of Chapter 9 and just go right into Chapter 10 after this. So this chapter is talking about what we call real numbers. Okay, so I have the two definitions listed there. It talks about an irrational number, where basically if it's an irrational number, you can't write it as a fraction. If it's a real number, if it's a rational number, you should be able to write that number as a fraction. Real numbers are the numbers that include all the rational and irrational numbers. So I really like this diagram that you see on your notes. You see here, and the small circle is just the natural numbers, which start at 1 and go up from there. The whole numbers are the natural numbers, but it also includes 1, so 0, 1, 2, 3, 4. The integers include all the whole numbers and their opposite, so that's where the negative numbers come in. And then you have the rational numbers, where you have all of your decimals and your fractions. Now, and keep in mind that the decimals are only included if you can write it as a fraction, because we do know that there are some decimals that you cannot write as a fraction, such as pi, square root of 2, and then these decimals that don't ever terminate or repeat. Kind of the easiest way, if you're looking at a number, to tell whether it's rational or irrational, first of all, if it's a fraction, it's going to be a rational number because it's already written as a quotient of two integers. If it's a decimal, you're going to look at the decimal part of it, and if any of those numbers repeat, you can consider it a rational number. Now, if you're looking through it and you're not seeing any pattern or anything that's repeating it, it doesn't look like it's ever going to end, you can go ahead and classify that as an irrational number. So that's what we're going to do first, is we're going to classify the numbers as rational or irrational. So the first one is 1 over 5. Okay, well, in order for it to be an irrational number, I can't write it as a quotient of two integers. Well, that's what 1/5 is. I'm taking 1 and I'm dividing it by 5. It's a quotient of two integers. So yes, it's a rational number. If it's already written as a fraction, it's going to be a rational number because that's what the definition of a rational number is. If I have 1 over 9, okay, well, same thing. It is going to be a rational number. Now, one more thing that you can do to classify these, if you plug these numbers into your calculator, okay, well, 1 over 5 is going to give you a decimal of 2/10, which is a decimal that terminates, right? It ends. If you plug in 1/9, it's not going to terminate, but if you plug 1/9 in your calculator, you're going to get 0.111111 for the rest of eternity, which we call 0.1 repeating, which repeats. So repeating or terminating decimals are considered rational numbers. Now, if we get into these square roots, let's say I have the square root of 22. Now, if you plug that into your calculator, you're going to get a number that looks like 4.69041576. So when you're looking through those numbers, there is no pattern. There is nothing that's repeating. If you notice that there's nothing repeating and it doesn't ever terminate, then you can go ahead and consider that an irrational number. If I have the square root of 64, okay, well, hopefully you guys recognize that the square root of 64, it's equal to 8. So since it's equal to 8, that is a whole number. That is a rational number. So we are going to go ahead and say that is rational. All right, the other thing is we want to be able to compare rational numbers. So I'm going to give you two rational numbers, and we're going to use less than, greater than, or equal to complete this statement. So for the first one, if I have the square root of 5 and 11 over 4. Okay, one of these numbers is rational, one of them is irrational. Hopefully you recognize that 11 over 4 is the rational number. It has to be. It's written as a fraction already. So square root of 5, if you punch that in your calculator, you are going to get 2.236, and it just keeps going and going and going. It never repeats, it never terminates. Okay, if you plug 11 over 4 into your calculator, or you turn that into a mixed number, you should notice that it's 2 3/4, which is the same thing as 2 75/100. Now, once you write them in decimal form, hopefully you can tell, okay, well, this is the bigger number. So the square root of 5 is greater than 11 over 4. So my suggestion to you, write them as in an equivalent form. So most of the time that's going to be a decimal. Okay, let's do one more of those. This time, let's compare 2 square roots of 3 and 31 over 10. Okay, so like I said, we probably need to change them so they look the same. So let's change them into their decimal equivalent. So if you plug 2 square roots of 3 in your calculator, you will get 3.464, and it's going to go on and on and on and on. If you plug 31 over 10 in your calculator, you're going to get 3.1. Hopefully you recognize that this will be the larger number, so 2 square roots of 3 is greater than 31 over 10.